ATME has one of the best infrastructures supporting passionate professors and vibrant students. ATME was founded in 2010 and since its inception has grown to adopt innovative teaching practices and student-centered policies that help our students become industry-ready and thoroughbred professionals in the global society. Within a short span of 8 years, ATME has created a milestone in the history of engineering accredited by NBA. NBA is a signatory to the Washington Accord. We are one of the 29 engineering colleges out of 240 in Karnataka to hold NBA accreditation. The Vidya Asare Scholarship Scheme awards scholarships to PUC students entering Year 1 who excel in academics. ATME promotes community engagement through collaborations with industry leaders, internships, and projects. ATME CE has 6 research labs with 16 PhD faculty members. Industry giants like Cisco and Freenest Technologies have set up labs and training centers within our campus. ATME CE is also a remote center for IIT Bombay. Turning Point device software called iCloud has been implemented for all the departments, which helps students have an interactive session through questionnaires, individual response cards, and analysis. Our centralized library has a collection of more than 15,000 books and journals and 13,000 ebooks. It also has a study center which caters to students, faculty, and researchers. Our auditorium, constructed on international standards, can house an audience of 400 and is embedded with the latest technological systems. We also have a well-equipped placement cell that has multiple discussion halls and interview chambers. Our spacious and well-equipped cafeteria maintains a high standard of hygiene and waste management. The common area is not only a place for students to unwind, but also to discuss and collaborate on projects and research. ATME's annual cultural fest, Atmiya, seeks to address social causes and create awareness with several publicity events. Integrating these numerous activities and the entire management and operations of the Institute is our state-of-the-art ERP solution that ensures efficiency and transparency. We are constantly striving to fulfill our mission of development of academically excellent, culturally vibrant, socially responsible, and globally competent human resources.
Good morning. I am Srivatsa, Assistant Professor, Department of Civil Engineering. Welcome you all for 5-day webinar series on design of RC structure, construction practice and its management, which will be held from 14th to 18th of this month. In this regard, I would like to thank the ATME management, Dr. L. Baswat sir, Principal ATME CE, and Mr. Manu Vijay sir, Associate Professor and Head of Civil Engineering Department for providing an opportunity to organize this webinar. No event is successful without the participant. Around 350 plus participants have registered from different parts of the country, and thank you all for the support and interest shown towards this event. I extend my sincere thanks to the resource persons who, in spite of their busy schedule, have accepted our invitation to deliver the lecture. I also extend my thanks to the faculties of Civil Engineering Department for their immense support in bringing this webinar into action. Now I request Dr. Akshaya BJ, Associate Professor, Civil Engineering Department, to address the participants.
Namaste and good morning to one and all. I heartily welcome you all to this webinar series. ATME College of Engineering was started in 2010 with 4 courses: computer science and engineering, mechanical engineering, electrical and electronics engineering, and electronics and communication engineering branches, with a vision of imparting global standards in technical education. In the year 2011, civil engineering branch was established. Since its inception, the organization is reaching the benchmarks of quality education. Our college was awarded as the most promising upcoming private engineering college in the year 2012 and best emerging private engineering college of Karnataka in 2013. In 2019, 4 of our BE programs, that is civil engineering, electrical and electronics engineering, electronics and communication engineering, and mechanical engineering, got accredited for 3 years by National Board of Accreditation. The present event, webinar series on design of RC structures, construction practice and its management, were organized in the view of bridging the gap between the industry and the academia. Webinar series is scheduled for 5 days from 14th to 18th of July. More than 350 participants have registered in this event. During this COVID-19 pandemic situation, I hope this webinar will serve its purpose with which it was organized. I thank you all for participating in this event. Have a great day and thank you very much.
Thank you, sir. Now I request Mr. Puneet K, Assistant Professor and Convener of Webinar Series, to introduce the speaker of today's session.
Good morning all. I, Puneet K, welcome you all to the first session of the 5-day webinar series. And it's my pleasure to introduce today's resource person, Mr. Kushal S, Design Manager, Vision Structural Design Aid, Bangalore, who will be delivering a lecture on analysis and design of RC buildings using ETABS. Mr. Kushal S completed his BE in Civil Engineering from PES Mandya and MTech in CAD Structure from PES Mandya in the year 2015. Mr. Kushal S has designed structures up to G+25 and over 3 million square feet with RC conventional system and RC wall system. His expertise is in structural designs and has diversified experience in designing residential buildings, IT parks, office spaces, industry buildings. He is skilled in earthquake analysis and also in the optimized design of tall structure. some of his major projects includes Kesagrande Crescendo Chennai, the Address Tech Park Chennai, Ibis Hotel Mumbai, Autoliv Industrial Building Bengaluru. So now I request Mr. Kushales to take over the session.
Hello, Kushal sir. Hello. Participants, please mute yourself and please turn off your camera. Kushal sir. Hello, Kushal sir. Hello. Hello, Kushal sir.
Hello, hello.
Please bear with us for a few minutes because of technical problem.
Hello, anyone? Hello. Hello, hello. Yes, sir.
Hello, Kushal sir. Really? Okay. Sorry for the technical issue. We will be back in 2 minutes.
ಈಗ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿದ್ರಪ್ಪ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿ. Hi Vatsa, am I audible?
Hello, Kushal sir.
Am I audible now? Hello?
Yes, sir. Yes, sir.
Am I audible?
Okay. Am I audible now?
Yes, sir. Yes, sir.
Thank you. Thank you. Is this screen shared?
So no, sir.
Okay.
Yes, sir. Yes, sir. Hello, Kushal, sir.
Correct. Now it is visible, right?
Yes, sir. Yes, sir. Yes, sir.
Good morning, all. Sorry for a bit of hiccup due to technical issues. And I welcome you all for today's technical workshop. Today we are here to discuss on design and analysis of RCC structures using ETABS. Okay. So guys, before getting into the technical part, I would like to brief you all on the job history in civil engineering industry, which is much more essential than discussing on the technicals. Okay. Guys, as you all aware, before 2000, there were no much companies or industries in India to offer jobs for civil engineering industries or any discipline, engineers from any discipline. And hence, greatly for the engineers from civil engineering discipline, the only options left were to become a government engineer or to become a contractor. Post year 2000, because of technological revolution in IT sector, corporate culture started booming and more industries stood offering jobs to engineers with higher pays. And this trend was at its peak between year 2003 to 2006. Suddenly, somewhere in year 2006, a sudden downfall in the economy. Guys, someone share my copy. Hello. I request all the participants to mute their microphones. Right. Okay. So that is how the IT sector or corporate culture was booming in India, and it was at its peak between year 2003 to 2006. Suddenly, in the year 2007, we were all aware that there was a sudden downfall of the American economy, which in turn impacted on the IT sector jobs and also every engineering discipline jobs in India. Engineers with skill sets and talent managed to survive in the industry, and this was about the recession that has happened in year 2007. After that, once again, our job market started picking up, and it was started to picking up exponentially. But again, somewhere in the year 2013, because of the developmental activity getting reached its saturation, we witnessed a second set of recession somewhere in the year 2013-14. And now the current situation, because of this pandemic status, is much more worst. Engineers have already lost their jobs, and it is a very tough time for the freshers, for the graduate engineers at entry level. It is a very tough time now, and hence I would request you all to have little patience in learning and developing your skill set for thriving and surviving in this industry. Moving forward, we will be looking at the design and analysis of RCC structures. Guys, it was also mentioned that it is discussed using ETABS. I would like to highlight to you all that, see, these ETABS, SAFE, STAAD PRO, ANSYS, any of these softwares, please treat them as a tool, just as a calculators, which will ease your calculation activity. Nothing else they can do. It is just as good as you are left to solve a structural analysis problem with the help of a scientific calculator. Only by virtue of having the scientific calculator, you cannot able to solve a problem. You cannot tackle a problem. You will have to be having a thorough subject knowledge, and this scientific calculator can only ease off calculation activity. Otherwise, the rest will have to be a thorough subject knowledge. Having said that, moving forward, we will be looking at the roles of a designer, a design engineer. See, the fundamental role is to see that the structure which he is on to design, it has to stand safe throughout its intended period of lifetime. That is the foremost fundamental requirement. And in addition to that, in a day-to-day industrial practice, he has to meet architectural requirements. He has to analyze the structure, design, detail, and on releasing the drawing to the site, he has to coordinate the design intent with the site team. Now, we will be discussing on meeting the architectural requirement with the help of structural systems. Okay. Guys, we will be having several structural systems. Say it may be conventional beam slab systems, a flat slab system, or structural steel system. And also it may be even a composite systems. Now, the basic question is how to decide which system we are going to adopt. See, I would like to discuss with you one by one. Is the drawing screen visible? Guys?
Yes, sir. Yes, sir. Yes, sir. It is visible, sir. Could you zoom in? Could you full screen it, sir?
That I'll do. I just checked. Okay.
Yes, sir.
Okay. Just moving forward, being a structural engineer, what do we do is, how our structural engineering firm works is, we will be getting the architectural drawings. The architectural drawings will capture all the requirements of the client who is about to build that structure, whether the purpose of the structure or the functionality requirements within the structure. All of these fundamental requirements of the client will be captured in the architectural drawings, and an architect will share his design intent capturing the client's requirement with a structural engineer with us for moving forward. And this is a simple residential building, a G+2 villa building, considered for the simplicity of explanation. And you can notice here the drawing contains ground plus three upper floors, in fact, plus terrace. This is the section which also explains the same. The drawing contains ground floor, first, second, third, terrace, and a roof. Headroom. So with this background, this is a residential intent. This building is for residential intent. We can notice the column to column grid may be hardly 12 to 13 feet. Okay, the column to column distance may be hardly 13 feet, which means say somewhere around, it will be hardly less than 4 to 5 meters. Moving further, this is the architectural drawing of a different project, and the principal intent of this usage of this building is a IT space. It's a IT building dedicated for embassy in Bangalore. And here, since this is being used for the office space, you cannot have the columns very close as we had in the residential buildings. In residential buildings, the rooms will be so spaced that no rooms, no bedrooms, no living rooms or dining rooms, kitchens will be much spacier than 15 feet, which will be your 5 meters. And exactly to that extent, you will be having the partitioned walls. See, this is your bedroom and it is 20 feet by 10 feet. And exactly to that extent, you are having the partitioned walls. Even with 20 feet, the column to column distance will be not more than 6.5 meters. So with this architectural intent, we can space the column very close by. Whereas in the another problem, we are able to provide the column to column distance like say 11 meters, 12 meters. Okay. Here in the IT spaces or office spaces, you cannot give the columns close by because you will not be having the partitioned walls, just like in the case of residential buildings where the rooms will be having a definite partition walls to separate it from other occupancies. And with this difference in the requirement, we are forced to increase the column spacing in the commercial or office spaces, and we can give the closer column spaces in the residential units. Even in case of apartments, you will be having the similar kind of column arrangement where you can restrict the column spaces well within the 5 meters grid. In case of office spaces, the column spaces will be at least 12 meters, 11 to 12 meters grid. So having said that, when we go ahead with the closer column spaces, the beam depth will be proportionately lesser. Say somewhat 450, 600 beam depths can be achievable with the column grids lesser than 5 meters. In the case of office buildings, where the column grids are 11 meters, 12 meters, the minimum beam depth shall be 750 mm, 900 mm, 1000 mm, having which there will be a serious concern on the headrooms. See, consider in a resident in any structure. I would request the
Hello. We request the participants to mute yourself. Hello. We request the participants to please mute yourselves. Sir, yes, sir, you can continue, sir.
Thank you. So moving forward, with this higher column to column grids, we cannot achieve the lesser beam depth. We cannot restrict the beam depth to 450 or 600. And with a higher beam depth, let's say the structure has the story heights 3 meters or 3.2 meters or even 3.6 meters. See, even with 3.6 meters, with 1,000 depth of beam, you will be achieving only 2.6 meter floor to floor height. And beneath which you will, since this is a commercial space, you will have to be having AC ducts, you will have to be having fire safety measures, fire lines, fire safety measures should run below your beams, AC ducts should run below your beams, a fall ceiling, say additional 400. So even with 3600 mm story height, the achievable space may be somewhere around 2.2 meters with conventional beam slab system arrangement. And for any office space with only 2.1 meter or 2.2 meter story height, it is not functionally feasible. The internal story height will be say somewhere around 7 to 8 feet with the beam slab arrangement, with a regular arrangement like this. With the regular flooring arrangements like this, where you will be having columns tied with beams on all sides and the slabs are supported on these beams. With this conventional method of arrangement, you cannot achieve the story height more than 8 feet in the commercial spaces, and that is not desirable. See, with it will be very suffocating in the commercial spaces with lesser story height. Hence, to achieve the greater story heights, what we will be doing is we are going to change the structural system. We will be adapting a system called flat slab system, where we are eliminating all the internal beams. Here, the beams will be provisioned only at the periphery, and inside the slab is directly resting on the columns. Okay, and the beam column system will be provisioned only at the periphery, and no beams will be provisioned inside the structure. With this, what we are going to achieve? There will be a draw or a column capital right beneath the column slab junction, and hence the thickness of the slab at that junction will be say around 450. So we are achieving a greater story to story height by avoiding the beams which we had in the residential systems. In the residential units, since the column to column spacing are very less, since with that lesser column to column spacing we can achieve lesser beam depths, we will be moving ahead with the conventional beam slab systems. Whereas in case of office spaces or IT parks, since it is an office space, the column to column spacing will be widely spaced, and say it will be double the space than that it will be in the residential buildings. Proportionately, the beam depth will be requirement will be double. It will be say 1000 or 1200, which is not at all possible, because if you are going to provide a beam say of 1000 mm depth between these two columns, there will be a hindrance made for the movement beneath that beam. There will be no sufficient headroom, because of which the people beneath the beams may feel suffocated. So with this background, I would also like to explain you when we are going to consider the steel structures. See here, this is a drawing of different project where the column to column spacing is 21 meters. Even the flat slab cannot support this longer spans, and hence here we are adapting the system to structural steel. Okay, so basically the fundamental governing factor to adapt the load path system or framing system is our column to column spacing, and this column to column spacing will be governed based on the intended usage of the structure. Here the intended usage of this structure is for residential purpose, and all the residences will be having well defined rooms, bedrooms, living rooms, kitchen, which will be not spacious, not widely spaced, and hence at every partition wall we are able to capture or provision the columns. Moving next, this is a office space where the requirement is wider column to column space. With this requirement, we are unable to satisfy or restrict the beam depths to provide higher headrooms, and hence there will be a different structural framing system or load path supporting system will be defined here with flat slab system. Moving forward, this is a conventional center or a say an auditorium where you will be requiring wide space, much wider space, say somewhat around 21 feet, sorry 21 meters. This is 21 meters, and when it is 21 meters, it is impossible to support it with RCC, and hence we are switching to structural steel. Moving ahead, there is one more system called composite system, which we will be adopting when the structure is well built. Say we have already built structure and the floor to floor height, it may be an industrial building. In industrial buildings, the floor to floor heights will be usually 12 meters, 12 to 14 meters. With that, if any client approaches you for addition of intermediate level, a mezzanine level, then you cannot have the floor with steel, and RCC inside already built structure will be tedious. So we will be defining a system called composite system, where we will be having steel beams supporting the structure. See, these are all your steel beams and steel columns to support the intermediate level slab, because you are going to use that slab as floor. You are going to walk on that, you are going to sit on that. Having a steel sheet will introduce vibration and will create sounds, which is not desirable for the working purpose, and hence we will be having a thin layer of concrete RCC above the decking sheet, which will be of steel. This decking sheet will be of steel and this hatch will be of concrete. So together they are two different materials, and hence we term it as a composite structure. So with this, I hope I have narrated or explained you the way we try to adopting or consider the various supporting systems for the load part transfer, considering the intended usage of the building. The only governing factor for deciding which system we need to begin with is the intended usage of the structure. Okay. So with this, as we said, we will be re-looking at the roles of designer. He has to meet the architectural requirement. He has to analyze the structure which he is going to design, and his designs should be detailed in the format of drawing, which will be sent to the site, and the designer should also coordinate with the site team, explaining his design intents to the site engineers, without which site engineers can create blunders at site. Without having the proper knowledge on the design intent, a site engineer can create a blunder which will cost many lives. So moving forward, he has to very initially decide on the structural system to meet safety and architectural functionality requirement. That is what we discussed so far. The structural systems are as follows, like conventional beam slab systems, which we usually adopt for the residential buildings, for high-rise apartments too, and flat slab systems, which we will be usually adapting for the office spaces. The structural steel systems, which we will be adopting for the convention centers or auditoriums, where the column grids will be more than 20 meters. In flat slabs, the feasible column grid would be, say, somewhere around 13 to 11 meters, whereas the conventional beam slab systems may be adapted when the column to column grid will be somewhere between 7 to 4 meters. Steel structural systems will be adapted when the column to column grid is more than 12 meters. There is one more kind of system that we discussed, that is composite system, which we will be usually adapting when we are doing addition or deletion work in an already built up structure. Generally, this composite system in India is used when we up to do an addition or deletion work in an already built up structure. Okay. Next, moving forward, we would start with what is analysis of a structure, and we can define it like we do a behavior study on structural members or load path systems for various conditions. That is what we can say analysis of a structure. Okay, and this structural system or framing system will be done based on how effectively we can transfer the loads from the slab to the foundation. Our load path system will be very simple. Our loading will be acted on the slab. The slab in turn transfer its loads to the beams. From beams, the load will be transferred to the columns, and at the end it will be transferred to the soil. So this entire mechanism is what we term it as a load path, and our structural system, framing system, should be defined in such a way that this load transfer should happen in a very efficient way. Efficient in the sense it should be very safe as well as cost effective. That is what we term it as efficientness. Okay, and we are restricting our today's discussion only to gravity load analysis and design and not on to the seismic. But seismic and wind, these lateral loads will be having a greater impact on the structures, especially whenever it is a high-rise structures or whenever it is a long span structures. So you cannot directly ignore the lateral loads. It has to be considered in a definite amount, but only for today's discussion, because of the time constraint, we are restricting ourselves for the gravity load analysis. And why do we do this structural analysis? We do structural analysis to confirm the load transfer mechanism is as defined as it is in the framing level. See, in the initial level, when the architectural drawing comes to us, see, when the drawings are shared with us for the structural working, architectural drawings are shared with us, we will be defining the column locations and the beam arrangements considering the load path mechanism. Okay, and the analysis we carry out is to make sure that my structure is behaving exactly the same on how I have defined in this framing layout. Okay, and continuing further, for designing my structure, I will be needing the forces. The forces will be the end results of your structural analysis. You can just recall whatever you have done in your structural analysis 1, structural analysis 2, and from your strength of materials. The end results used to be your bending moments, shear force, torsion, axial forces. These are the fundamental forces that will be made used to design each and every structural component, like your beam, your foundation, your column, and your slab. Okay, so as I said, the structural analysis is carried out to extract the end results, that is your reaction forces, to design each and every structural members. And also to understand the criticality of the structure. With the help of structural analysis, you can identify whether the given sizes are sufficient for the intended loading. Now, to begin with, what we will be doing is, based on the experience for the given loading, we will be proportionating and positioning the column sizes and locations. See, it may not be final. This is the initial or conceptual drawing, and we will be making sure whether my given dimension is adequate for the given loading. See, we have defined the column to be dimensioned as 230 by 600. Okay, this is the initial assumption we are making, and only after the structural analysis, only after we are able to understand the reaction forces that are developing in this column, we will be able to conclude that the assumed size is adequate for the given structure. So this is also what we will be doing with the help of structural analysis. So our discussion is, why do we do structural analysis? Because even after completing my education, I was wondering why exactly we do structural analysis, and all these years of all the work we did, I am able to conclude that these are all the essential things we will be extracting on doing the structural analysis, and this is why we need to do the structural analysis. And now, moving forward, to analyze any structure, we will be having several methodologies, and the widely used three methodologies are experimental approaches or experience, analytical approaches, numerical approach. Experimental approach is something that you will be creating, or you will be casting a prototype exactly the same as the intended structure. You will be allowing it to cure for 28 days, and you will be applying the loading, and you will be analyzing the structure. This is how we will be analyzing the structure with the help of experimental approach. The next is analytical approach. That is what with the help of your Carney's method, your moment distribution method, we will be able to analyze the structure, and that approach we will be categorizing under the unit called analytical approach. So both of these are time consuming. An experimental approach needs minimum of 40 to 60 days for doing the complete analysis of the structure, because the curing itself will take up to 28 days. So in this current market where time is everything, we cannot definitely rely on the experimental approaches. Moving forward, your analytical methods, your Carney's method, your moment distribution method. Imagine, even with all pressure in the examination hall, you can able to crack a problem, say somewhat around 1.5 hours to 2 hours, a simple frame problem. Imagine when you are up to design or analyze a structure up to G plus 20 to 25 stories. It is next to impossible analyzing a G plus 20-25 story with the help of your Carney's method, moment distribution method, because first is time constraint, and even after you giving the complete dedicated time, there will be a human tendency to make errors. So with all of too many calculations involved, the errors with human tendency is unavoidable, and hence even we cannot totally rely on the analytical approach for the professional activities. The third thing is numerical approaches. These numerical approaches will be done with the help of computers. Okay, and the very famous or popular methods under numerical approaches are your matrix methods, your finite element methods, which you will be using to do the computer codings, and with the help of which you will be you will be inputting all the input parameters to the program, and you will be analyzing the structure with the help of the program. That is what all about your numerical approach. And currently what we are using in the industry are STAAD PRO and ETABS. It is based on your FEM method. It will be the fundamental basis of your ETABS and STAAD PRO softwares will be finite element analysis method. So this is very widely used in maybe 90 to 95% of the industry practitioners all over the world will be using ETABS or STAAD PRO. That is very much dependent on finite element or the fundamental basis of your ETABS and STAAD PRO is your finite element methods. Okay. See, the very essential requirement even before we start using these softwares, the basic requirement we need to understand is that all of these softwares will behave exactly how you treat them. See, any structure that is modeled and analyzed, the results will be dependent on the inputs you are giving into the software. The software doesn't know whether the column to column spacing in the drawing is 11 meter or 10 meters. While inputting, if you make a mistake, say 7 meters or 5 meters, the software will grab it and the results will be corresponding to it. So the fundamental requirement while using these softwares is you have to be very cautious. The modeling should be done same as that it is in the drawings, and any deviation, any mistake while inputting the data, you will end up with the erroneous results. Okay. So this entire process of numerical approach or the analysis and design of the structure that we do in the ETABS will involve 3 steps, will involve 3 stages. The very preliminary stage we term it as pre-processing stage, and the next will be solver, and finally it will be post-processing stage. In the pre-processing stage, you will be inputting all the required data to the ETABS. It is just like you will be modeling your geometry into the ETABS. You will be defining the materials, the construction materials. See, the grade of concrete will be defined, the grade of steel will be defined, the sizes of the columns, the sizes of the beams, thickness of the slabs will be defined, and it will be modeled accordingly. The loading, the intended loading, say the slab may be used for the residential purpose or even for the office purpose. The residential loading will be different and an office loading will be different. So the intended loading will be assigned to the slab accordingly. So with all of these data inputting, we will be assigning the boundary conditions and we will be meshing the geometric model. So the loads we will be considered based on our IS Codal provisions, and this is a very vast subject which we cannot discuss well within 2 hours, and so I am just giving you an idea of what exactly the process is, how exactly the system it is going to be followed. various loads that we will be defining to the structure, helipad loadings as well, wind loads, earthquake loads. So with all the model is done, the loading is applied, you will be analyzing the structure with the help of solvers. The tool that will be helping you to run the analysis in a structure is termed as a solver. And the results you are going to read once the analysis is done. The process of that we will be terming it as post-processing. The various results we will be extracting from the ETABS is the column reaction forces, which we will be extracting for designing the footings, the beam forces like beam deflections, bending moments, shear force, torsion in a beam, that will be extracted, or the results that will be extracted in the case of beams. So this is a brief on the entire process that is involved in the structural analysis. Prior to the structure, starting to the structural analysis, the process what we follow and the subsequent phase what we follow is what briefly discussed. With this on board, I would like to just demonstrate you guys to model a simple residential building, how exactly it will be done using ETABS. And on opening the ETAB dialog box, you will have to be starting with new model, where you will have to be customizing your inbuilt settings. In general, the unit system we will be adapting is metric. Since we are switching to or sticking to the Indian standard codes, all the code of practices should be of Indian standards. And this is what the necessary changes you will have to be doing at the very early stage. You will have to be changing the unit system to metric. All the code of practices should be of Indian standards. Moving further, we will be considering G plus 3-story building. Okay, there is an option called bottom story height, and this height will be the height from the top of the foundation till your plinth beam level. The height will be, say, somewhat 1.5 meters, 5 feet in practice. Generally, it may be even more than 1.5 meters, but this is mostly used as 1.5. And the story heights will be in general used as 3 meters, which may be much more in case of commercial spaces. Now, since the number of floors we are considering is 3 floors and there will be 1 terrace story, we are considering altogether 4 stories. And the grid of the columns in both directions is done as 4 meters by 4 meters. See, the column grids may vary depending upon the partition walls grids. You cannot space a column, you cannot space this column somewhere here. This is a door opening. So the column position will be depending upon your architectural walls. Okay. So for now, just for the simplicity of modeling, I am considering a 4 meter by 4 meter grid. Okay. So with this, we are starting with the definition of the properties. So what you will be doing is you start from the define tab and You start with the material properties definition. To begin with, the region we are in, India, when we are considering concrete, we will be having various grades of concrete inbuilt in the ETABS. Whichever grade you are requiring, you can choose it. And M25 grade of concrete is defined. Again, new material. We will be again choosing Indian region. Material type is now changed to rebar. See, steel is different and rebar is different. Rebar is something that is used with RCC. This steel is something that is used in structural steel designs. So in ETABS, the term steels is used only for the steel structures, and rebar should be used when you are modeling the RCC structures. And in rebar, you will be having various grades of steel available, rebar steel available. They may be 415 or 500, choosing FE 500 grade. Now, to begin with, you are defining the frame sections. In this frame properties definition, you will be switching to add new property. Various shapes available for concrete, steel and composite materials. Now choosing the concrete rectangular section, you will be defining whether it is if it is a beam, you will be starting with B 200 by 450 EM25. This is what we follow in the industrial practice for the identification whether it is beam or column, for the identification of the size of that RC member, for the identification of the grade of concrete used. So we are defining this section as beam. We will be getting into modifier show rebar. Design type should be beam and rebar material type to be FE 500 for longitudinal bars, and for the confinement bars it should be FE 415. So this is how we have defined the beam. The unnecessary unwanted sections will be deleted using delete multiple options. Now we are defining the column section. Again it will be 200 by 450 EM25. Longitudinal bar will be 500, confinement 415. The design type will be column. Clear cover for the columns less than 200 or 200 will be 25. And the bars along 200 width direction will be 2 numbers. Along 450 direction will be 4 numbers. And that has been changed. This is how we will be defining the column section. Now we will also be requiring to define the slab section. Slabs can be of two types, one-way slab, another is two-way slab, depending upon the aspect ratio, depending upon the ratio of your longer span to shorter span. You will be deciding whether the slab is one way or two way, and you will be one way slab 125 thick, EM25. Okay, thickness will be 125. This will be the modeling type should be membrane, and the load distribution will be done in one-way type. You will also be defining the slab as two-way slab 125 thick, EM25 grade. This will be not checked. This is a two-way slab. The difference between defining the one-way and two-way slab is, for one-way distribution you will be checking this dialog box. For two-way distribution you will be unchecking this dialog box. Okay, with this you have defined the material property, and to define it you are getting into this define tab. Under that, material properties tab, add new properties, India. If you are about to define the rebar steel, you will be changing it to rebar. If you are about to define a concrete, you are changing it to concrete. And the grade of steel or concrete will be changed with the help of grade drop box. Okay, this is how you will be defining the materials, and you will be defining the beam, column and slabs frame sections. To define that, you will be getting into section properties. Beams and columns falls under frame sections. In the frame sections, you are going to start with add new property. Since this is the RCC structure, you will be selecting a section shape under concrete, and here you will be defining whether it is a beam or column, B and C for beam and column, and you will be defining the width and depth, and also the grade of concrete. Grade of concrete of the material will be changed here, and width and depth will be changed here. The type of the section, whether it is column or beam, that has to be decided or defined here with design type. Accordingly, the rebar material that you have defined will have to be changed in this dialog box. Longitudinal rebar type will be Fe500, confinement rebar type will be Fe405, and the clear cover to the column main bars will be defined here, and also the column reinforcement bar arrangement will be defined here. And 4, whatever you give the input in this section, the same thing will be replicated in this drawing. Okay, and this is how 2 and 7 you can notice. This is how you will be defining the beam or column frame sections. And finally, we had also defined the slab section here, and slab section can be defined as in two ways. It can be either one way or a two-way slab. You will have to be inputting the membrane type, and to define it as a one way, you will have to be checking this dialog box, and you will be uncheck the same to define it as a two way. The thickness of the slab will be defined here. Okay, so this is how we are defining material properties as well as the section properties. Once we are done with defining materials and sections, we will be starting with the modeling. See, the moment you select this drawing tool, column drawing tool, it will be displaying you the property type it is having by default. It is beam B200 by 450 M25. So this is why it is very important to define whether it is a beam or column. With this you can directly get to know what exactly that section you have defined as. Now taking this as C200 by 450 M25, and the orientation of the column can also be changed here. See, now it is 90-degree orientation, and again you can adapt it as 0-degree orientations too. Okay. By default, the modeling will be happening at the topmost story. Okay. You can again draw in at each and every grid point, or you can simply replicate this. Edit. You will be selecting all of these columns. Edit. Replicate. See, the grid is 9 meters along the y direction. So I am inputting -9. Apply. So these 4 set of columns is been replicated. Now what I will be doing is I will be modeling my beams. I am checking the defined section is beam. Once the beam modeling, you will have to be model it column to column. Okay, next we will be modeling the slab. By default, the property of the slab will be deck 1, which I am changing it to slab 1 way. Okay. All right. Now, modeling of columns, beams, and slab as well is completed. See, this arrow indication is indicating the load distribution, and it is precisely indicating that the load distribution is happening only in the one single way. And now we will have to be assign the loading to the same. So the loads can be acting on slabs as well as on the beams. All of the walls predominantly will be built up above the beams. So you will have to be calculating the loading that is happening because of the construction of the brick walls. That particular loading will be assigned onto the corresponding beams, and the intended usage of the slab, whether this slab is used for the residential bedroom, residential living room, or whether it is used for the toilet purpose, whether it is used for the office space. So each and every different usage may have different loading. See, the residential bedroom or living room loading, the live loading will be say 200 kg, whereas the commercial loading will be 400 kgs, which will be double. So based on the intended usage, the different loadings will be assigned as on the slabs. Shell loads, the loading you will be selecting those slabs on which you are intending to assign the loads. First of all, I am going to select only this slab. Assign shell loads uniform. This I will be defining the live load. Live load will be, say this portion is my toilet area. The live load for the toilets will be 200 kg per meter square, which will be your 2 kilonewton per meter square. I am applying that. It is applied. 2 is applied here. So this may be my residential living rooms, and again the live load for the residential living rooms will be 200 kg per meter square, which I have assigned. Next, I will be replicating all of these. Edit, replicate, again -9, again -9. It is asking. Okay. All right. So this is how a simple way of modeling the beam slabs in a residential unit. So, and also we will be assigning the wall loads on these beams. Assign frame loads distributed. Say if you calculate for a 3-meter story height, the wall loading for 200 thick with brick wall will be somewhere around 10 kilonewton meters. That is assigned here. Now the similar thing we will be replicating story wise. Edit, replicate story. Till now the replication is done in plan along the linear motion, but now we are doing it story wise. The current plan is of story 4. Now I am replicating it to story 3. One more story is been added. Next I am replicating it to story 2. Again I will be replicating it to story 1. Okay. Again I am replicating the same to base. Okay. See here I am selecting the dialog box to one story, and in the base I will be having only column and foundation. No slab and beams will be there. I am deleting the same. See, let us name the stories first for the better understanding. This base will be foundation level. Story 1 will be your ground floor. Story 2 will be your first floor. Second floor, your terrace. Okay. So in the foundation level, you will be having only column and your foundation, nothing else. So we have deleted all the beams as well as your slabs at foundation level. In ground floor, we may only have since there is no basement, the soil will be filled up till the ground level, and hence no suspended slabs will be there. We are deleting the slabs at this level too. The beams will be there for the tying purpose, and these beams will be termed as plinth beams. And simultaneously there will be beams and slabs at every intended floor levels. This is how we will be completing the creation of geometry, that is modeling it, definition of material properties, definition of section properties, and the loadings that is being defined. See, there are many other patterns of loads you can define, say your earthquake loads, seismic, which we termed as EQX and EQY. Here the Codal provision should be 1893, 2016. You can also define your wind loads. Code of practice IS 875 2015. So, and these defined loadings will have to be assigned here. We had live load defined by default, and this live load is being assigned. All of these properties and loadings that you are going to define in this tab, that will be in turn assigned on your geometric model, that what you are going to create. Okay. So with all of this done, you will be assigning the boundary condition to your columns at base. See, this is completely fixed condition with all translation and rotation are restrained. This is a pinned condition where only translation is restrained and rotation is allowed. This is the roller condition where translation is allowed in two parallel directions and only in the vertical direction it is restrained. This is free condition. So now we are assigning the fixity condition at the base of the column, and we will have to save this first. Now you are setting the model for run. Before running, there is one exercise we will be doing is to check whether the model you done has any warnings or. So model has been checked, no warnings, no warning messages were generated. Usually what it happens is whenever you draw a beam above the beam by mistake. See, there was a beam earlier. I have drawn one more set of beam, and now if I check the model, sorry, we have not checked it here. Okay, there is some technical issue with the software. This is a different laptop I am using, but usually the error messages will arise whenever you are modeling a slab above the slab and a beam above the beam. So that is why we will have to check the model before running it for the analysis. Just if in case if you have by mistake modeled a member above the member, that may be a reason for the erroneous results. and hence you will have to be checking your model once even before starting the analysis. Okay, now we are running the analysis. The structure is analyzed, and this process will be done with the help of solvers. Can you please unmute yourself? Okay. So this analysis process will be done with the help of solvers, and the solvers are based on artificial intelligence. Here it will be self-solving your analysis. So once the analysis is completed, next you can post-process your results, that is the forces. See various results like the bending moment diagrams, shear force, bending moment and shear force for beams we just had a look at it. Now the axial forces in the columns can also be witnessed. Okay, the axial forces in the columns, and also the base reaction at the column. This will only be furnished for the unfactored combination. You will have to be defining the load combinations at default design combos for frame designs. Okay, one more set of combos for base reaction. Here you will be having both of this with scale factor 1. Okay. Display. Combo your base reaction. Apply. So the base reaction at every column can also be post-processed. So guys, the process before running this analysis, what all the activity we did, like creating the geometry, drawing the geometry, defining the materials, section properties, loadings, assigning of the material property and loading, all of this is pre-processing stage. Next, in the solver stage, the program, the ETABS, it artificial intelligence that is being imparted to the ETABS. You will have to be doing nothing if you are done with correct inputting the geometry, the material properties, section properties and loadings. The ETABS by default, using the artificial intelligence, it will do a finite element analysis using the solvers, and on the completion of the analysis you can able to read the results of the analysis, like your base reactions, your beam reactions, moment, shear forces, your column axial forces, if torsion in beams any, even that will be, we will be able to read. All of these results are analysis forces. the results of analysis. So far we haven't conducted any design in this model, and so far what we did is only we have analyzed the structure and we have read the analysis results. See, designing is not a big deal in ETABS. It is just you will be getting into this design, you will be selecting this concrete frame design and selecting this tab, start design check. Even the design of the RC members is also being done. This end result of this design is you will be getting the necessary steel that needs to be given to these beams, to these columns, to stand safe during the intended usage. Okay, so that is how we can carry out this intended tabs. And guys, as I said, you will have to be using this ETABS or any softwares just as a computer. See, just because this ETABS is giving some result, you cannot directly consider the same thing and start delivering to the site. Okay, you will have to be having a feel on the structure, whether the results that is being displayed in ETABS is correct. So you will have, see, one thing is that based on the experience, based on the several structures that you have designed, you will be getting a fair feel or idea whether the results that is being extracted from ETABS are correct or not. Otherwise, you will have to be correlating these results from ETABS using any analytical methods like your Canis method and your moment distribution method for any at least one frame. If you can able to do that, like wait a second. Okay. See, for considering for any one of these frame, if you can able to conduct the Canis method or moment distribution method of analysis, and if your analytical results are matching with your ETABS, then you can conclude the results from your ETABS is safe and you can carry out your designs. Otherwise, again here, due to some erroneous input at the stage of pre-processing, the entire design procedure may end up with errors and a big blunder can happen at site level. Okay, so having said that, see, this RCC designs and analysis, even using ETABS, cannot be addressed in one single session of 2 hours. So just with the idea or with the try for motivating or inspiring you guys, I had to start with briefing you on the current seriousness on the job for freshers like you, and moving further we discussed on the roles and responsibilities of a designer and what exactly he will be doing sitting in his office is what we discussed. Studying the architectural drawings and how exactly he will be deciding the structural framing system or load path system to analyze the structure, and why exactly we do structural analysis. So what we have discussed, and a simple model is also being done with the help of ETABS just to give you a fair idea. But trust me, what we have discussed is just say only 5%, not even 5% is what we have discussed. And with this knowledge sharing, I seriously advise you guys, don't be under the impression that we have covered all the aspects of structural engineering or design aspects, and this at least requires say some 60 to 70 hours, and in very compacted manner or in very crash course manner, even if we discuss, this may at least require some 60 to 70 hours. With this I mean limited or constrained time slot, the whole idea is just to give you an exposure on what exactly the structural analysis and design is using this ETABS, and what exactly you will have to be doing after this is you will have to be studying more and more of structural analysis and design books, but ultimately only when you can able to work on any particular project you can able to get the fair industrial practice idea. Otherwise, only taking some textbook examples, textbook activity, I don't think even that will be able to impart you the fair level of knowledge sharing. And so I would like, maybe in several other sessions, if your college permits or if you guys are interested, we can really start with the activity of an workshop or a course kind of a thing on the RCC structures, design and analysis of our analysis and design of RCC structures using ETABS, which we may plan after this, maybe if you are all interested and if your college is uh, able to do it. Okay, with this I am able to conclude today's session, and now you can unmute yourself and you can able to start interacting if there are any queries regarding anything what we discussed today.
Thank you, Kushal sir. And it was very informative and you have detailedly explained the usage of software. And regarding participants, if you have any queries, you can unmute yourself and you can ask the queries.
Sir, good afternoon, sir.
Yeah, good afternoon.
Hi, good afternoon.
Sir, sorry, sir, I joined in between.
Okay.
I would like to know your name, sir.
My name is Kushal.
You are based in Bangalore, sir?
Yes, correct. I'm based in Bangalore, but I am basically from Mandya. Tell me what it is.
Sir, this is regarding, as you said, we have learnt only 5% of the entire usage of the software and structural design. So I would like to learn balance 95%. So how you can help me, sir?
Okay.
If you
See,
are
guys, if you are interested, if you are interested and willing, you can able to meet us in Mandya, or if we can also do this an online workshop every day, say for 1 hour or 2 hours. Say after 7 o'clock in the evening, because we will be working till 6:37, and after say somewhere between 7 to 8 o'clock, if you are all willing, we can able to start a interactive session, just like it will be a work from home situation for you guys. We will be working based on a project. Okay, it will be like a work from home situation. You will be working for us based on a live project, and which will deliver the complete knowledge transfer based on the industrial practice.
So can you please share your mobile number, sir?
Yes, it is 7259.
7259.
Again, it is 259.
259.
812.
Okay. Is any other participants request to ask your queries about the session?
Good morning. Actually, good afternoon. Sorry.
Good afternoon.
Sir, I wanted to ask, like near my house, I observed commercial building which was like 3 to 4 stories tall, The thing is that they had replaced all the frames, like the beams, the columns, and the slabs, with complete structural steel, of huge dimensions. Do you think that is more feasible, and does it have more long life than the reinforced concrete?
See, guys, the reinforced concrete is more durable, I would like to say, because it is maintenance free. Okay. When it is purely a steel structure, you will have to be periodically maintaining using your paint. You will have to be periodically maintaining with help of paints, and you will have to be checking periodically whether your steel members are corroding, because it is exposed to the atmosphere and the threat for corrosion is high when it is a purely steel structure. Whereas in case of an RCC structure, your reinforcement bars will be embedded with a clear cover inside your concrete. So with this, we can say your RCC is more and more durable than your steel without any maintenance. I add that point, without any maintenance. Continuing further, considering your time constraints, your steel construction is very fast. Maybe for that intended project, the construction using steel material, I mean fully steel material, may require 1 year. Whereas for the same project, the construction using RCC may require 2 years. It's almost double in the case of RCC. But again, the steel structure costing is very high. It will be at least 30% costlier than your 30 to 50% costlier than your RCC structures. So
Got
considering
it,
all
sir.
of these parameters, based on your client, you can decide what to go ahead with. I
Sir, but
hope your
again,
Can you
again,
please tell me about the moment releases?
please one at a time.
sir,
One
considering
at
the
a time.
load transfer and in load bearing capacity, steel is way better than RCC, right? If we take it off the
See,
equal.
no, you cannot generalize the statement like that, because your steel is not capable of taking care of buckling. See, the moment you come with steel, the sections of the steel will be much sleeker, much slender, say
Yeah,
compared to your RCC columns. So when your story height is higher and your cross section of the member is lesser, possibility of steel member instability is very high. Okay. At the same time, your RCC structure is very much stable with the heavier cross section. So you cannot generalize a statement like steel is much efficient in taking the loads. Proportionately, each and every material like concrete and steel will be having its own capacity. So you,
got it.
based on the section.
Got that, sir.
Hello.
Thank you, sir.
No, thank you.
Thank you, sir.
Tell
Hello.
me, tell me. Hi, tell me.
Can you please explain regarding column orientation?
Okay. See, the column orientation basically should be done in the major axis. Okay. The column orientation of the column should be basically done in the major axis. In the sense, what is major axis in the sense? Now,
Please read the session which is present in the class section.
see, considering this plan, the span of this beam is more compared to the span in other direction, and the column orientation should be done in such a way that it is done in the loading way. Okay, if you orient this column in another direction, the effectiveness of this column will be lesser. Okay, see, but you cannot stick to a point that I will be only orienting the column in the loading direction, because the architectural intentions may be different. Say my architect needs a door opening here in this corner. I cannot say that no, strictly I will be requiring the column in this direction. We will be compromising in some cases based on the functionality requirement, and we will have to be reorienting such a way it has to be designed in a compromised manner. Okay. So
Sir, but
there are various
right to the one you explained is not oriented in the direction of maximum bending load.
in the sense.
Just to the right, I mean the fourth grid line, the second column. It is not oriented towards the maximum span.
Correct. See, what will happen is this, since this is the periphery, my walls, architectural walls will be in this direction. I may not be having an architectural wall here. So I cannot give a column orientation such a way that it is protruding into my usage space. See, if I am reorienting this column, see, there may not be a wall in this direction, and the only wall is happening in this direction. So this additional width, considering the wall thickness is 200, the additional 250, since the depth is 450, the additional 250 will be projecting inwards, and no architect, or it is definitely very awkward situation to visualize. And hence what we will be generally doing is, if you can notice here, all of my columns will be concealed within my walls, within my architectural walls. See, I cannot reorient this column so that if I am able to reorient it in another way, there will be this projection. There will be this offset from the wall, this projection of the column from the wall, and which will be very awkward to look at it. So in general, what we will be doing is we will be concealing all of the columns into my architectural walls. That is how every column location is decided. Okay. If very preliminarily we will be focusing on my framing system. Tell me.
For the secondary beams, do we release the moments?
Obviously, we will have to be releasing it. See, what it happens is, if we do not release the moment here, this beam, see the moment at this junction of P12 is not released. If suppose if it is not released, my B2 will experience a torsion. Okay. You can make a choice actually. If you are releasing this moment, you may not be able to design this beam to additional torsion. If you are not releasing this moment, you will have to design this B2 for the additional moment, additional torsion that is being introduced because of this moment not released at this junction. Okay, it is actually a choice. If you are releasing, you are designing this beam without torsion. If you are not releasing, you will have to design this beam with torsion. And with torsion design may actually fail this beam, and hence if you are unable to satisfy the design of B2, by default you will have to release this moment. Anything else?
How to give floor loading for a cantilever projection of the slab?
The same way how you define to every other floors, you can able to give a floor loading even for the cantilever slabs. Say we will be defining one more section type for that. Shell 125 it will be with M25. See, for the cantilever slabs, we will have to be considering modeling type to be shell. I'm assigning shell section to be shell 125. Same way you will be assigning your shell loads. Since this projection may be a balcony, the balcony loading will be 300 kg. We have assigned that. Maybe your doubt is the edge parapet loading on this balcony. Is it so?
Yes, sir.
Okay. See, there are two different ways of assigning that loading. In ETABS, we are not designing the cantilever slab. We are designing only beams and columns. ETABS software is exclusively for the design of frames, that is beams and columns. No foundation and slabs can be designed using ETABS. For designing of the foundation and slabs, we will have to be using a different software called SAFE. So here the assigning of load is with the idea to transfer all the loads to my beams and columns. You can assign the parapet loading. One of the ways you will have to be calculating the entire wall parapet wall load and divide it with the help of this area. Say my parapet wall length is say 1.2 on either side, 2.4 meters, and this will be 9 meters. So altogether it will be around say 11.4 meters. This is 1.2, 1.2, 2.4 and 9, which will be 11.4. Thickness will be 0.2 and density will be 20. Height will be say 1.2 meters. The overall wall loading of this parapet shall be 60 kilonewtons, and the slab area will be 1.2 by 9 meters. 10.8 is the area of your slab. This current area is 10.8 meters square, and the overall parapet loading will be say 60 kilonewtons. 60 by 10.8 will be say 5.5 kilonewton per meter square of the loading. So you can either assign it directly as shell area, addition 3 plus say 5.5, which will be 8.5. Okay, or otherwise you can also do one more thing. You can define a none section and assign your parapet loading on this. That's it. Anything else?
Excuse me.
Thank you.
So may I?
You can ask the question now.
Hello?
Rahul sir, you can ask the question.
Hello.
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 Rahul, sir?
Hello.
Yeah, I can hear your voice. You can ask the question now.
Tell me, sir.
Yeah, sir, I would like to ask one thing. In the slab definitions,
Proceed, sir. Proceed.
yeah, for the cantilever slab, you have considered shell thin, and for the other slabs, you have considered membrane. Like, what
Yes.
exactly is the difference between that?
Hello. So the main question is the technical difference between a shell and a membrane. So,
Yes.
see, a membrane is something that is having the support in all four sides. Okay. And a shell is something which is not having the support in all four sides. Okay, and a membrane transfers the load to the beams and then to the columns. A shell will directly transfers the load to columns. It is capable of directly transferring the loads to the columns. So this is a vast subject which may require at least say 30 minutes of explanation on the theoretical background, why exactly this difference is happening, and which we can definitely have some other day.
Thank you, sir. And a request for the participants, a form has
For
been
the
posted.
cantilever projection, if there are two beams where we have columns, then will it act as a membrane load or a shell, sir?
I didn't get your idealization, how exactly you are looking at it. Can you please re-explain your intent?
Yeah. You have designed the projection as a shell. So if there are beams at the
So you
column,
need to say there is a beam projection, there is a beam projection, and on these two beam projection, if you are going to support this slab, how will be the behavior? Is that your question, sir?
Yes, sir, exactly.
So then you will have to be reassigning this as one way, and again you will have to be changing this as provided you are assigning the property of the beam there. Okay, this is how it can be done.
Okay, sir. Thank you.
Thank you. There's a request for the participants. Hello. A request
Hello,
for the
sir.
participants.
Tell me, what's it?
Sir, how can we assign the load of false ceiling directly on column provided the beam is not provided there?
So why do you need to assign the false ceiling load directly to the column? You can assign it to the slab if you don't have any beam there. You will not be directly you will not be directly fixing your false ceiling to the column. The false ceiling fixtures will have to be fixed to the slab. You cannot fix it to the column directly. Correct?
Okay, sir. Okay, sir.
Thank you, sir. A request for the participants. The form has been posted in the chat box. Please rate the session. That will be considered as an attendance for today's session.
Hello, good afternoon, sir.
Yeah, good afternoon, sir. You can ask the question.
Good afternoon, sir.
Yeah, good
Am I
afternoon.
audible?
Yeah, you're audible, so you can ask the question now.
Yeah, so I am Manu. I'm from SJC College of Engineering. I'm currently in my third year of construction technology and management. So currently, because of the lockdown, I wanted to do internships, a technical internship in our field, but I'm unable to do so. So can you suggest any possible internships which we can do remotely from our houses?
See guys, for those who are all really interested and willing, we can have this two type of internship activities. One is purely for design. Here we will be considering a zone 2 building for residential and commercial, and we will be discussing complete modeling the same using ETABS, SAFE and STAAD PRO wherever it is essential. We will be carrying out all the stability checks and designs that is required for each and every element like foundation, columns, retaining walls, and also the design and detailing of the same will be done as per the IS Codal practice. So the complete load path definition, framing system definition, the modeling using softwares, the analysis, the stability checks, and the design for the complete project will be done. Okay, that is one of the course we are actually planning for 30 hours. It will be, and next course will be structural drafting, which we will be doing for drafting of the structural elements and its detailings, like foundation layouts, foundation in the sense like we will be able to draft the framing system, the reinforcement details for slabs, the reinforcement details for the beams, likewise for the footings and columns, staircases. All of these will be taught in this current drafting activity. So we have modulated two of the courses. One is for the structural designs, where we will be only concentrating on modeling, analysis and design of structures. Next is for structural drafting, where we will be only concentrating on drafting and detailing of the structural elements using IS codes as well as using AutoCAD. So interested candidates can just WhatsApp us or call us or mail us to this email ID.
Thank you.
Hello.
Is
Hello.
there-
Organizers, the feedback forum is not visible.
Sir, it is posted in the chat box.
Sir,
No,
unable to open chat.
So
No,
we
no.
can't open the chat box. It's not accessible.
It is saying chat in channel meetings is only available to the team members.
Sure, sir. We can send you the form in through email. You can
Please.
submit feedback there.
Okay, okay.
Sir, if there is any queries regarding the session, if anyone is interested, you can ask the queries.
Yeah, Mr. Kushal, what is the fees for these two trainings?
May I know who is this?
Yogesh.
Okay, you are from which year?
Only related to session.
Sir,
Hello?
Hello.
Participants, if you have any queries regarding the session, you can ask now.
See, the fees for these courses will be decided based on the strength of the participants. If the participants are in good number, the fees will be reviewed and finalized accordingly. Basically, this is not for the revenue purpose, since everyone are idle now with the lockdown situation. We are planning an activity for the students for with the work from home situation and with the work from home culture, for you to analyze or for you to have a design industry knowledge by sitting at your home, by spending say 1.5 hours a day from your home for say a month of 1.5 or 2. So interested participants can please WhatsApp us to this number or mail us to this email address, and maybe by end of next week, with the interest of the candidates or participants, we will be able to finalize the fees and we will be launching this course say by August 1st.
So one more doubt, sir.
What's it?
Hello.
Hello.
Sir, ETABS does design considering face of the member, and STAAD PRO does the analysis considering center line of the member. So which is the beneficial one, sir?
You mean to say ETABS will be doing the analysis considering the face of the member? In the sense, I didn't completely got your point.
STAAD does the analysis considering center line of the member, and ETABS does analysis considering face of the members.
Which member you mean to say, beam or column?
Column as well as beams.
See, no, even in the STAAD PRO, you will be defining the complete member size. See, in the graphical user interface, GUI, STAAD PRO may show it has only a line element, but it has the property completely defined for the 200 by 450. In ETABS, in the plan, you may feel it, the exact shape of the column is provision, but even in the ETABS, it is just a line element. Okay. In the graphical user interface, you may able to see it as a column. See, for example, even in ETABS, this column will not be exactly modeled like this. See, this is just a line element. Even in ETABS, it is a line element. Only in the graphical user interface, they have been modeled. So they have made it or look like a area element. Okay, but still it is a line element in the ETABS too. The analysis procedure both in ETABS and STAAD are same. Only the difference that you may look at is in the procedure ways. See, there are this ETABS is mainly for the building sector. It is precisely for the analysis and design of the buildings, whereas your STAAD is a universal software. You can use it for modeling any type of building, any type of structure, whereas your ETABS is only precisely done for the buildings analysis. So that is why you will be directly having your stories defined, your grids defined. And again, the definition of certain load parameters like your earthquake loads, wind loads, your construction sequence analysis, your P delta analysis options. See, this ETABS has much more advantage and simplicity in these parameters, that is in earthquake analysis, in more advanced analysis. Even in STAAD, you are able to conduct all of these advanced analysis, but the procedure is quite tedious. That's it. Otherwise, the results of ETABS and your STAAD will be same. There won't be much difference.
Thank you. If you have any queries regarding the session, you can mail us. We'll get you back. Thanks, Kushal sir. Thanks for your wonderful session. And we shall end up the session, and we'll meet you tomorrow for the second session. Thank you all. Thank you for active participation. Thank you. We shall end up the session. Thank you.